Okay, now let's take one problem. So let's take the first problem itself and let's start solving it. So let's start solving this problem, and of course I need not tell you the algorithm. Let's do it by Dijkstra's uniform cost search, whatever you like. So my initial condition is at C1 comma SFO at C2 comma JFK at P1 comma SFO at P2 comma JFK, and I'll not write down these are atemporal. So this is what I call as my source, and the priority queue only has the source. Does not matter whether you're doing the A star, BFS, DFS, I'll apply all actions. Now remember, these are action schemas. Actions are after applying substitution. In general, my action schema is something like action, object A, B, C, all the way up to, or let's generalize, it's A1, A2, all the way up to AN, and I don't assume that they are domain specific variables. So this could be substituted by any one of the N symbols, any one of the N symbols. Okay, N has been used. So this could be specified, replaced by any one of the S symbol, any one of the S symbols. So it's basically S raised to power N actions, where S is the number of symbols that you have, all distinct, ground, database semantics, function free, and N is the arity of the action schema. So that's the total number of actions which are possible. Not all of them will be applicable. So for this problem, let us try to apply all the actions. So let's see which one of them are applicable. At C comma A is applicable for C is equal to C1, A is equal to SFO, and C is equal to C2, C is equal to JFK. So these are valid substitution at P comma A. So it's valid for P is equal to P1 and A is equal to SFO, and similarly for the others. So you could go around doing like this around over here. Similarly for the unload, you can see what all are possible in C comma P. Now luckily we know that in C comma P there is no substitution possible, because if something is not mentioned over here, it's negative, and in C comma P is false for all CP combinations, so unload is not applicable. And fly P comma from airport plane P, so that's the smallest action. So let's apply this one, fly P comma from comma to. So I could, which all actions are applicable? P should be at from, so I can either apply P is equal to P1 and from is equal to SFO, or P is equal to P2 and from is equal to JFK. Let's do the first one. P substituted by P1 and from substituted by SFO, and 2 substituted by, oh my god, I do not know. So let's substitute it by Delhi, and let's get a state. In the next action, let's substitute it by New York, and let's get the state. Next one, let's substitute it by Bangalore, and let's get the state, and so on and so forth. And you can see it's already not happening. So the 2 airport, just because there's no restricting precondition that could tell me this is the 2, it could be substituted by anything. And because it could be substituted by anything, there are 2 problems now. Number one, if I need to generate in all the children, I need to do the substitution so as to have an actual state. Then after getting the children, I can do heuristic, say star, whatever, but to generate the children, I'll have to do all substitution. And that means the branching factor is horribly high. And because of that, this search is already impractical in the classic sense as of now. Modern day planners can just leave 2 unsubstituted and still go on. That's not what I'll be discussing. So, at least my one step of the forward search, doesn't matter, DFS, BFS, A star, was S's extract from Q and for all applicable action A, considering all action schema and substitution. Then of course I'll generate children. The problem is this step is too computationally expensive. And because of that, the forward search, at least as of now, is not making any sense. So what do we do? All algorithms failed with a stroke of a pen. We try to do it exactly the other way around. So, oops. So what we do is we try to invert the search and we try to see, can we apply a backward search instead. So I'll try to do a backward search. The backward search is where I go from the goal and I go towards the source. So let's take the goal. Luckily the goal is at C1, JFK and at C2, SFO. Now remember, the thing about the sources, anything which is true is written, close world assumption, anything which is not true is not written, close world assumption. That's not for the goal. Goal, if it mentions anything true at C1, JFK, it means C1 has to be at JFK. If it mentions at C2, SFO, it means C2 has to be at SFO. On the other hand, if it mentions not at RK, Delhi, it means RK should not be at Delhi. It should not be in a state that you're calling it as the goal space. That you're trying to call it as a goal. If any state has RK, del at, it's not a valid goal. Anything which is written as negative should be false, and anything which is not specified, like what about P1, what about P2, what about C3, what about all the different planes, all the different cargoes about which nothing is said, they could be true, they could be false, they could be anything. So accordingly, when I write down this goal state, I mean C1 is at JFK, C2 is at SFO. It does not mean all the other things are false. It means all the other things currently for the goal are called as do not care. I don't care what they are, whether they are true or whether they are false. I absolutely do not care about that. With this, let's try to see what happens. Now, in a forward search, we were looking at things which, we were looking at actions which were applicable. Now what we'll do is, we will see what all actions can we apply. Let's first ground zero do exactly the same thing, and Where was the problem? The problem was fly. So let us say P1 from JFK, oops, to Delhi, to anything. So this too could be anything, to New York, to, okay, JFK is at New York, to Bangalore. So now it turns out that this action is still applicable because source I do not know. I'll add those things to the source and the action will become applicable. From the goal I'm going towards the source, and this action is still applicable. And because this action is still applicable, I still have that problem that the branching factor is infinite. To make this action applicable, all that I will do is I will add a at P1, JFK. So this action becomes applicable. These are obviously applicable. And now fly becomes applicable. That means I could do any substitution. It still leads me to the goal because, of course, a condition of the effect is at P, 2. But remember I said that things which are mentioned in the goal need to be true. Things which are not mentioned at the goal, they could be true, they could be false, they could be anything. I don't care. Anything not mentioned in the goal is do not care. So I have the same terribly large branching factor, and backward search does not solve the problem. And therefore, I apply a constraint on a backward search. Now the interesting thing is, if I do apply this action, then this is also a valid goal in a backward search because I'm not changing anything of these two variables. They remain as it is. And I add new variables which I do not care at the goal. So if this was the goal, why did I take a step ahead? That makes absolutely no sense. And because this was only the goal, I would have stopped right here. So let's do it again. So to make this action applicable, I have to add at P1, JFK, and this applied on this, that add list, that delete list. In order that to be true, I need this to at the goal. So now do the add list thing, add the items in the add list, delete items in the delete list, you get this thing, but this is also a valid goal. And because this is a valid goal, after having the goal, doing one step ahead has absolutely no sense. So I'll apply a constraint. I will apply a constraint and I will now say that I will so that's backward search. So you only select actions which are relevant, which means they attain or they satisfy or they obtain at least one sub-goal. Any action which does not get at least one sub-goal is not a relevant action. So forward search, we apply applicable actions, precondition satisfied. Backward search, we apply relevant action, at least one goal should be met, which means my constraint is, so I haven't defined subgoals. Subgoals are nothing but the clauses of your goal. That's the first subgoal, that's the second subgoal. It's a set, you could invert it up. That's the first subgoal, that's the second subgoal. It doesn't make a difference. So I must either get subgoal 1 or subgoal 2. The last action was not relevant because it neither got action subgoal 1 nor it obtained subgoal 2. So Now it's the same backward search. Backward search is into my priority queue, and I will apply all the action. Instead of checking the precondition to check the relevance, I'll check the goal. So I am trying to locate in actions where at C1 comma JFK is a goal. So do I have at C1 comma JFK as a goal? So that's one. At C1 comma J, oh, oops, I have to check for the goal. So there is no at C1 comma JFK here. There is at C1 comma JFK here. So that's the first option that I have. And there is at P comma 2, but this P is a plane. I need a cargo. So that's only one option. So my action is, of course, unload. So now I will do one thing in order to save space. I will no longer be writing substitution separately. I just say unload. What should be C? I need to unify C comma A with C1 comma JFK. So C is equal to C1 and A is JFK. So unload C comma P comma A. So I've taken a shortcut here. I did not write down the substitution separately, and I did not write down the unify separately. Otherwise, what I've done is, so I have unified at C comma A with at the subgoal that I want, C1 comma JFK, which gives me C substituted with C1, A substituted with JFK, and then I put this substitution in my action schema. Now you see P is non-guessable, and I have the same old problem that now that means if there are 100 planes, I can substitute it with all the 100 planes and it will still be valid. Here what I'll do is I'll cheat. I'll say let P be unsubstituted, or I say P is some P dash out of all the planes P1, P2, P3, just that I currently do not know the value of it. Let's start doing it. The moment we need a specific value for P, we'll fill it up. So otherwise I'll get too many children. So what happens over here is unload. So now I need to add the precondition. It's a backward search. So I'm checking for the effects and I'm adding the precondition. So let me write down the precondition. So it's in C comma P, C is C1, P is P dash. At P comma A, okay, I think I draw the circle right at the end, my bad. And to clarify, let me number this up. So these numbers can go. So I need to add 1 and 2. So I need to say in C is C1, P is P dash, and at P comma A. A was JFK. And the subgoal that wasn't met, of course, needs to be added. Now I can depth first search, select any subgoal and keep on going in this manner. Or you could say breadth first search, you add all the other children. Now it's up to you. Now one thing interesting that you would have observed that in the entire process, this participated, these 1, 2 participated. What happened to this poor guy? Where is it? I don't care about it. Where did it go? So another effect was that should have been added to the goal. So because there are many children adding it to the goal, let me write it down over here. Not in C1 comma P dash. Why didn't I write this thing down? Goal, it's do not care. Goal, it's do not care. These things need to be true. I've ensured one of them is achieved. actions are relevant. There's nothing false, otherwise that would have also been added. Anything which is not specified is do not care. So this was do not care, and that's exactly what I did. I did not care about it. I did not care about other sub-goals being produced which are do not care. Be very careful. And to show you an example that do not care also, you sometimes need to care. Let's take a synthetic problem. I say that my goal is a single literal G, so there's only one sub goal in my goal. Simple problem. My actions are, so that's the one sub goal, that's the only sub goal. In fact, let me make it even simpler. G1, G2. My actions are A1, which has a precondition as A, or let me not use A, which has its precondition as B, and the effects as G1 and not G2. And that's only one action, so let's apply it up. So I say let's select the sub goal, so one needs to be satisfied. And what action will we apply? A1, it's all the ground, so it's not an action schema, it's an action. There are no symbols that could be substituted. So what do I get? I get precondition B, and of course I need to add G2. And what did I not care about is not G2. Satisfied, wonderful. So let's apply this in real life. So I say I've had a source as BG2. I apply the action A1. What happens? Add list G1. So add G1, delete list G2, not G2, delete list. So I get G1, which is in the goal, perfect. I don't get G2. So there are two conditions around, and now let me add to my definition. So backward search, you only select actions which are relevant, which means they obtain at least one sub goal, and they do not negate another sub goal. So the last action was problematic because it was attaining one sub goal G1. However, it was negating another sub goal G2. You cannot do that. So you do care about the other effects that you are producing just to ensure that you are not negating a sub goal, and that is what is also important for you to check in a backward search. So very quickly, so what really happens around is, let me pick in another sub goal, which is this at p dash jfk, and let me see if I can, of course it will generate multiple children. Let me see if I can just generate one of them at p dash jfk. So can I search for a plain p dash? First let me check which of the action schemas is relevant, which action schema has at p dash jfk at the effects. So at c p, no, that does not satisfy. At c a, no, that also doesn't satisfy. At p 2, yes, this satisfied for p is equal to p dash and 2 is equal to jfk. So I do the substitution around over here, and I apply this action. So let us apply this up. So I say it's fly P dash from unsubstituted from dash 2 is substituted JFK. And once I do that, I of course, now there's a negative effect, so just check that you are not negating one of the applicable actions. So is at any p comma from, so the only constraint that I add is that of course, in order for me not to negate this at p dash comma JFK, so the only thing that happens is that from dash cannot be equal to JFK. Otherwise, it will produce not p dash comma JFK, and there is a p dash comma JFK at around over here. And what I'll do is I will again add in all the preconditions. So at p comma from, at p dash comma from dash, there is no other, these are just domain variables, and I already had this, so let me add the other goals as well. At c1 comma p dash, at c2 comma sfo. Now you'll be wondering that, are the unsubstituted variables really increasing? Yes. Instead of p dash, I now have a from dash, so now there are two. The second thing is, where do I stop around over here, because they are unsubstituted variables. So eventually what I'll start doing is I'll start looking at the source, and I'll say that is there a p dash such that at p dash comma from dash. So this substitute, if I make this p dash is equal to p1 and from dash is equal to sfo, it's already satisfied, and anything already satisfied is done. Is there in c1 comma p dash? In c1 comma p dash? No. And of course that's true because I haven't applied the load. So let me apply another function. I'm restricted by space, so I'll not continue going around from here. What I would leave you around by the end of this thing is that you'll soon start seeing variables which are completely there. So p dash from dash or any other dash, some substitution makes it true at source. A forward search stops when whatever is specified in the goal as true is there in the state, whatever is specified as false is not there in the list of your state vector. Rest I don't care. Backward search stops. So a backward search shall stop if maybe by some substitutions all variables are satisfied by the source. Even in the normal backward search, we had exactly the same thing. If you apply the goal test, source, you just said that is exactly the same as source. And that's exactly what's the condition here. I get something which is exactly the same as what is my source. The two exactly match. And once I get that, once I get my source, a backward search, I just stop. The only difference is that for this p dash, you may have to try to give in some variable p1, p2. And after substituting p dash with a p1, p2, it should satisfy what is there at the source.